Hi, I'm Miss Hearn. Let's get started. Now we're going to move on to function notation. So when we know we have a function, we often use this notation f of x to represent the y value. And it's read f of x or f at x because what it represents is what is the y value when you plug in a number, a particular number for x. So let's look at this example. Instead of writing the equation y equals 3x plus 1, I've written the equation f of x equals 3x plus 1. Now, one unfortunate thing about this notation is it looks like I'm multiplying some variable f times x, and that's not what it is at all. So this is supposed to indicate that we're plugging in a certain number for x into our function, which we've given the name f. For example, let's look at f of 5. What does that mean? That means that we're plugging 5 into the expression 3x plus 1. So 3 times 5 plus 1, which gives us 15 plus 1, which is 16. So you could say f of 5 is 16. This is another way of saying that when x is 5, y turns out to be 16. So if we were to graph this guy, we would have the point 5, 16 on our graph. Okay, but we can plug other things besides numbers. We can plug variables in, and we could say 3 instead of x, we're going to put a plus 1. So f of a is 3a plus 1. We could plug a box in, a placeholder. So f of the box is 3 times the box plus 1. And I like to emphasize that you can put anything you want in that box, right? So for example, I could put, in that box, I could put a heart. So 3 times heart plus 1. In that box, I could put myself. So f of Miss Hearn equals 3 times Ms. Hearn plus 1. Anything you put in these parentheses is going into this box, this placeholder. All right, so the type of question you're going to see in our class in my math lab would be like f of x equals x squared plus 2x plus 9. That they're telling you is a function. That's why they're using function notation. And at the given values, we're supposed to evaluate that function at the given values of the independent variable. By the way, the x, the input, is sometimes referred to as the independent variable. And the output, the y, is the dependent because it depends on what you input. So if you see independent and dependent, they're just talking about the x and the y. Start with f of 1. So remember, my original function was f of x equals x squared plus 2x plus 9. And each of these x's is really just a placeholder. What I mean by that is we can put anything we want in there. So think of it as a box. Whatever we put in there, we're going to square it and we're going to multiply 2 times it, and then we're going to add 9 to it. Okay, whatever's in the box. So what if I put, for part A, I'm putting a 1 in the box, right? So I'm evaluating 1 squared plus 2 times 1 plus 9 for part A, f of 1. So that's going to be 1 plus 2 plus 9. All right, so we're going to have 3 plus 9 is 12. So f of 1 is 12. By the way, we were not asked this in this exercise, but that means that if we were to graph this relation, this function, we would have the point 112 on the graph. Part B, they're asking us to plug in x plus 3, and people find this very confusing. I'm going to give it a different color to emphasize that we're plugging it in. All right, so what are we really doing? We're putting it into that box. F of whatever equals whatever squared plus 2 times whatever plus 9. All right, so what's in the box this time? X plus 3. So we're going to take that guy and we're going to plug him in. And whatever we plug in, we square it, we multiply it by 2, and we add 9 to it. So I'm going to take that guy in my box, x plus 3. I'm going to square it. I'm going to multiply it by 2, and then I'm going to add 9 to it. Doesn't matter that it has an x in it. It's not the same x that you had up there, so don't get confused by that. So what are we going to do? X plus 3 squared. So we have to square a binomial. So we're going to have first term squared, x squared, second term squared, 9 squared, and twice their product in the middle. So that's going to be plus 6x. All right, and then plus 2 times x plus 3, so distribute 2x plus 6 plus 9. And so combining like terms, x squared plus 6x plus 2x is 8x plus 9 plus 6 is 15 plus 9 is 24. All right, so that's about as simplified as we can get. So what is that telling us? That's telling us anytime we plug in a quantity of the form x plus 3, the output, a corresponding y coordinate, would be x squared plus 8x plus 24. But all you need to put into MyMathLab is the answer here. Okay, part C. So this time, what are we plugging into the box? We have f of negative x. So negative x is going into the box. So we're going to get negative x squared, the quantity, the whole thing's being squared, so that turns it to a positive x squared. 2 times negative x is negative 2x plus 9. So that's how we would plug negative x into that function. Okay, so that's function notation.
I hope you found this video useful. If you did, please remember to like it.